All right, so we're looking at lesson 24 today. We're looking at freely falling bodies. So hopefully after this lesson you'll understand how freely falling bodies work. We call our downward acceleration of a freely falling body the acceleration due to gravity. And we've already talked about that number. Hopefully you've been using it. It's negative 9.81, and it's negative because you're always going towards Earth. You're going down. If we use English units, then it's 32.2 feet per second squared. So if they give it to you in English units, that's the number you would use. When we use the phrase freely falling bodies, it doesn't mean that a human is falling off of a building. It just means that a body or an object is free of physical restraints and the vertical velocity is free to change because of the acceleration that's caused by gravity. So it could be a human that is falling off of a building, but more often than not, it's just some random object. Think of a ball as more what we're going to be looking at. Just a ball dropped from the top of the stadium or out of the window or whatever. That's more what we're going to be looking at today. The two equations that we're going to use to solve these are the motion equation and the displacement equation. And we already looked at those. I'm going to write them just in case you don't remember. Hopefully you remember those two equations, but that's what we're going to be looking at today. Your acceleration due to gravity in these is always going to be negative because it's always going down. So you have to make sure to put negative for your acceleration. And then we're going to always assume that they are in free fall in a vacuum. And so we're going to ignore air resistance. So if you dropped a feather and you dropped a bowling ball, they are they're going to fall at the same rate because we're in a vacuum. There's no air resistance. All right, so let's look at this example. We have an object thrown downward at a velocity of 20 meters per second from a height of 120. How long will it take to hit the ground? So we're going to plug into both of our formulas. So we have V of t equals V sub O plus AT. And then our position, it's actually not X. Technically it's a change in Y because it's going downward. It's just a small change. Just because it's a vertical change and not a horizontal change. Left off the 1/2. Alright, so those are the two formulas. They tell us our initial velocity, because it's thrown downward, is 20 meters per second. So our V sub O is negative 20. And then acceleration is always negative 9.81. And we don't know our time. And then over here, the change in height is 120 because it starts at 120 and we want to know when it'll hit the ground. And then our V sub O, again, is negative 20. And then time, we don't know, plus 1/2 negative 9.81 and t squared. So we're going to want to solve this right equation because we don't know what the V of t is. We don't know what the velocity at whatever time is, so we can't do anything with it. So if we set this equal to 0, and I'm actually going to move everything over to the left side and set it equal to 0. So 1/2 times negative 9.81 is negative 4.905. So when I move that over to the left, it's going to be positive 4.905 t squared, and then plus 20t. And then, the change is actually a negative 120 because we started at 120 and then we went down 120. So it should be a negative 120. We ended at 0 and we started at 120. So minus 120 equals 0. And then from here, you want to use quadratic formula to solve this. So I'm just going to write what the quadratic formula is. And so use your calculator to get your two values. And you're going to get two different ones. One of them is going to be negative, and one of them will be positive. And so if you get your 2, you get negative 7.39 or 3.31. And we don't use a negative time, so it's going to have to be the 3.31 number. And it says, how long will it take for it to hit the ground? So this is whenever the height gets to 0. It's this time. So we just need to look back and see our sig figs. We have 2 sig figs in our problem, so we're going to do 3.3 seconds. So that would be your answer for how long it'll take to hit the ground. If you are taking calculus, if we haven't already done this, then we will be doing this before too much longer in calculus. So it'll give you a little bit of extra practice. So let's look at another example. We have a ball thrown upward from a height of 40 with an initial velocity of 10 meters per second. How long does it take the ball to hit the ground? All right, so again, we're going to start off with our 2 equations and see what we get. And again, it's changing y because it's a vertical change. So a ball was thrown upward from a height of 40 with an initial velocity of 10. So our v sub o is a positive 10 because it went up. And then acceleration is still negative 9.81, and then we don't know our time. So over here, initial velocity was 10 t plus 1/2 negative 9.81 t squared. And then the height. We started at a height of 40, and then we went down to 0. So the change is going to be 0 minus 40. So it's going to be a negative 40. We want to know how long it takes to hit the ground. So we're solving for our t. We don't know the v sub t here, so we're going to want to use the equation on the right. Just like we did last time, we're going to set it up to use quadratic formula. So we're going to move it over here and have 4.905 t squared, and then minus 10 t, and then minus 40 equals 0. And so use your calculator to get your 2 answers. So you're going to have negative b plus or minus the square root of b squared minus 4ac all over 2a. And if you get the positive number first, then you don't really need to redo it to get the negative number. So if you're figuring out which one's going to give you the positive, then feel free not to do it a second time. But those are the 2 that you'll get. And it says, how long does it take for the ball to hit the ground? Well, we don't use the negative number, we only use the positive number. So 4.05 seconds would be your answer. And we have 3 sig figs because the 2 numbers they gave us had 3 sig figs. So that's how you can do those freely falling bodies. And we're going to look at one more just to practice it. It says we have a ball dropped from a height of 40 meters. How long does it take for the ball to hit the ground? And what is the velocity just before it hits the ground? So we're going to start off with our 2 equations. our initial velocity, it says it's dropped. So right when we drop it, the initial velocity is actually 0. And then acceleration is negative 9.81 t. And so that's the velocity at whatever time. And we don't know what that is right now. Over here, initial velocity is 0. So basically this equation goes away. I mean, this term in the equation goes away. Then we have plus 1/2 negative 9.81 t squared. And then the change in the height is 0 minus 40. So we have negative 40 equals negative 4.905 t squared. And if you divide, you get 8.15 for t squared. And then you take the square root. And your t value, technically it would be plus or minus 2.8556, but we only take the positive for our time. And we're going to have 3 sig figs, so 2.86 seconds. That would be how long it takes to hit the ground. And then it also asks for the velocity just before it hits the ground. So what is the velocity at the time of 2.86? All you're going to do is plug it into this equation. So you're going to do negative 9.81, and it's actually going to be times the whole number in your calculator. So whatever that whole number is. And so you get negative 28.0 meters per second. And so that's how you can do freely falling bodies. They basically always use those two equations, and you just have to plug in the information they give you. And you do have to know if it was dropped, that means a velocity of 0, or if it was thrown up, that means positive. Thrown down, that means negative. You do have to know a little bit about them, but mainly you just use the equations and go from there. So your homework is 1 through 20 and the curveball questions, so make sure y'all do those so that we can go over any questions you have.